Imagine waking up tomorrow morning, you stretch, roll out of bed, and you walk over to pull back the curtains before dawn. You look out the window expecting to see that familiar, comforting glow of the crescent moon, but instead you find the night sky is just a complete, absolute void.
Oh, wow.
Yeah, I mean, the moon, the celestial anchor that's literally watched over this planet for 4.5 billion years, is inexplicably gone, just completely vanished.
It forces an immediate physical reaction just thinking about it, honestly. We anchor so much of our subconscious reality to the permanence of the night sky.
Right.
And when you remove the largest object in our orbital neighborhood,
Yeah.
you aren't just, taking away a light source, you are fundamentally breaking the mechanics of the Earth itself.
And that terrifying premise is exactly the foundation of the speculative piece we're exploring in today's deep dive, which is titled "The Moon Disappears." We're looking at the literal mechanical breakdown of our planet in the aftermath of this impossible event.
Yeah, it's quite the scenario.
It really is. The source material traces these cascading consequences from the immediate, just sheer panic of day one to the warping of time and physics, right through to the massive engineering adaptations and philosophical shifts that humanity would be forced to undergo.
And what I love is that the author doesn't treat this as just some magical vanishing act where people simply miss the moonlight.
Totally.
They really dig into this severe gravitational and frankly ecological debt we owe to the moon. So we're going to explore why losing it triggers a global catastrophe, but more importantly, how the ensuing chaos acts as this unprecedented catalyst for human ingenuity.
Okay, let's unpack this, because the piece starts on that first morning. People wake up, look at the news, look at the sky, and the initial reaction is just pure, unfiltered terror.
Exactly.
But what stands out to me isn't just the public panic, it's that specific detail about the scientific community being completely silent. Like, if you're living through this, your first instinct is to turn on the news and wait for some astrophysicist to explain the data. But the text notes that the telescopes and the observatories had absolutely zero answers.
Yeah, that silence from the scientific community is, I think, the first real psychological fracture for humanity in this scenario.
Yeah.
Because, science relies on cause and effect.
Sure.
Conservation of mass and energy dictates that an object a quarter the size of the Earth cannot simply cease to exist.
Right, it breaks all the rules.
Exactly. If it did, it would violate the foundational laws of physics. Gravity actually propagates at the speed of light, which means we wouldn't even know the moon was gone until about 1.3 seconds after it vanished.
Just over a second, that's wild.
Right, and in that exact moment, the gravitational tether snaps, the light cuts out, and all those mathematical models scientists use to predict the universe just become instantly useless.
And that leads directly to the physical chaos. The text details that the absence of the moon immediately devastates the Earth's tides.
Oh, absolutely.
Like, the oceans, which have been pulled in this rhythmic, predictable way for eons, suddenly begin to rise and fall in these entirely unpredictable, violent ways. Coastal cities are flooded, and millions are displaced almost overnight.
It's a nightmare scenario.
It is, but I actually want to push back on the physics of this for a second because, think of the Earth and the moon's gravity like two people holding hands and spinning, right?
Okay, yeah.
If one suddenly lets go, the other just goes flying. The oceans lose their anchor. But doesn't the sun also exert a massive gravitational pull on our oceans? Shouldn't we just be left with smaller but completely predictable solar tides?
Well, that is exactly the kind of question oceanographers would be frantically trying to answer in those first few hours. And yes, you're right, the sun accounts for roughly 44% of our tidal force.
Okay.
So eventually we would settle into a predictable solar tide. But the text focuses on the immediate, violent transition. Think of the Earth's oceans like a loose layer of gel wrapped around a spinning bowling ball.
Okay, I'm picturing it.
The moon's gravity is like a really powerful magnet, constantly pulling that gel into a massive bulge on one side. If you certainly switch off that magnet, that colossal bulge of water doesn't just gently flatten out.
Oh, wow. No, I guess it wouldn't.
Exactly. It collapses instantly, releasing just petajoules of kinetic energy.
So it's not just, a change in the high water mark. It's like a global sloshing effect.
Precisely. You have an oceanic rebound. That mass of water crashes back down and sends unimaginably huge displacement waves just rebounding across the ocean basins.
That is terrifying.
They would bounce off the continents, interfere with each other, and create these massive rogue waves and chaotic storm surges. It would take years for that violent kinetic energy to fully dissipate through friction before the oceans could actually settle down to follow just the sun's gravity.
Which totally explains the widespread displacement the author describes. I mean, if you live anywhere near a coastline, your centuries of tidal data, your almanacs, your seawalls, they are instantly obsolete.
Completely useless.
You just can't outrun or evacuate from an unpredictable ocean. But the flooding is really just the first wave of the disaster, no pun intended.
Right.
Because here's where it gets really interesting. As the text moves from the immediate aftermath into the medium-term effects, the loss of the moon begins to warp the actual fabric of a day.
Yeah, the displacement of that much water doesn't just destroy coastlines, it literally alters the planet's rotation. The text outlines that the Earth's rotation actually begins to slow down.
This is where the mechanics get incredibly bizarre to me. It's like a record player slightly losing its power, where everything just stretches out.
That's a good way to look at it.
The text states that this slowing rotation results in longer days and shorter nights. But if the whole planet is spinning slower, wouldn't the entire 24-hour cycle just stretch out equally? How do we end up with longer daylight hours but shorter nights?
Well, it really comes down to the loss of our axial stabilizer. The moon doesn't just pull the tides. Its gravitational mass anchors the Earth's 23.5-degree tilt. Without the moon acting as a counterweight, the Earth's axis begins to wobble violently. So what the author is suggesting here is that this immediate shift in our obliquity, which is the angle at which we face the sun, would plunge certain hemispheres into extreme, prolonged exposure to the sun.
So the actual rotational period might stretch to, say, 26 or 28 hours because of the massive drag from the sloshing oceans.
Exactly.
Like, the water moving toward the poles acts like an ice skater extending their arms, slowing the spin.
Spot on.
But simultaneously, this new, wild axial wobble means a continent could be suddenly tilted so far toward the sun that it experiences brutal, unending daylight, which is then followed by an abbreviated, deeply unsettling night.
Right, and if we connect this to the bigger picture, that combination fundamentally breaks the biological clock of everything on the planet. Human society, agriculture, animal behaviors. They're all entirely predicated on a stable circadian rhythm.
Yeah, everything is timed to it.
So the psychological toll of living through a stretched out, mathematically broken day is
Okay.
just immense.
And the text leans heavily into that double hit to human psychology. Not only are your days painfully longer, but when night finally does fall, the author describes it as growing far more unsettling.
Because of the darkness.
Exactly. We are plunged into this absolute pitch black void. It strips away this ambient nightlight that our species has relied on since we were literally hunting and gathering.
Yeah, we have a deep evolutionary fear of the dark scotophobia. The moon was essentially the original torch that allowed early humans to spot predators or, navigate terrain after sunset.
Right.
Losing it plunges the human psyche back into a primal state of vulnerability. But the ecological impact goes far beyond just human fear. I mean, think of the millions of species that rely on lunar light and lunar cycles.
Oh, for sure, like lunar navigation, sea turtles hatching and finding the ocean using the moon's reflection, or coral syncing their mass spawning events to the full moon.
Exactly.
There are entire ecosystems of nocturnal predators and prey whose very survival hinges on the specific phases of lunar illumination.
And when you drop that illumination to absolute zero, you blind those ecosystems. Moths and nocturnal pollinators lose their celestial navigation.
Wow. Yeah.
Even the base of the marine food web, like the zooplankton that migrate vertically in the ocean based on moonlight, they're thrown into complete chaos. The text suggests that the deepening darkness isn't just some spooky aesthetic change. It is the onset of a mass ecological disruption.
But I love that the author pivots right at this moment of maximum despair. We have coastal destruction, a wobbling planet, broken time, and ecological collapse. And yet the sheer absolute darkness actually pulls back a curtain.
It really does.
Because the text points out that the total lack of light pollution reveals a night sky blazing with 1,000,000 points of light. It allows stargazers and astronomers to see the universe in a way they never could before. Imagine looking up from your backyard and instead of seeing a familiar white rock, seeing just an absolute explosion of stars you've never witnessed before.
Right, it forces us to look deeper into the cosmos out of necessity. The moon is incredibly bright, and its glare actually drowns out massive portions of the night sky.
I never really thought about how much it blocks out.
Oh yeah. Ground-based observatories instantly gain a massive boost in effective sensitivity without lunar light pollution. The author notes that astronomers use this pitch-black sky to explore entirely new celestial bodies.
I just find this dynamic fascinating. You have the total breakdown of Earth's local neighborhood, but it opens up the wider universe. Astronomers are suddenly discovering new near-Earth asteroids, mapping distant exoplanets, and observing faint galaxies that were previously washed out.
It's a huge shift.
It sparks this massive, aggressive era of exploration. It's just amazing to see that duality of human nature right in the middle of this destruction.
This raises an important question, though, which is about human resilience. The text highlights this profound duality, that at the exact moment humanity is stripped of its primary celestial anchor, we don't just collapse into the dark. We use the darkness as a new lens to map out new anchors in the deep universe.
And that resilience translates directly to the ground level, too. The text shifts focus to the engineers and scientists who spend the following months and years developing new technologies to mitigate the disaster.
Yes.
They're out there designing entirely new systems to control the erratic tides and building innovative structures to protect coastal cities. But I really struggle to visualize how you engineer an ocean.
It's hard to wrap your head around.
Like, you can't just build a thermostat for planetary sloshing. What kind of technology is the author actually implying here?
Well, you certainly can't fight billions of tons of water with rigid walls. They would just shatter instantly. To control erratic, chaotic wave energy on a planetary scale, the engineering would have to be incredibly dynamic.
Okay, so what does that look like?
We are likely talking about deploying massive networked arrays of offshore dampening grids. Instead of trying to stop a rogue wave, these semi-permeable barriers would absorb and diffuse the kinetic energy, essentially using the principles of acoustic cancellation, but applied to hydrodynamics.
Oh, wow. So they are basically building artificial friction. They're forcing the oceans to burn off that pent-up kinetic energy faster than it naturally would on its own.
Exactly. And the text notes the construction of massive, innovative structures around coastal cities. This implies a complete revolution in civil engineering and material science.
Right.
Humanity is forced to invent things like self-healing concrete or dynamic hydraulic sea gates that can instantly adjust to unpredictable surges based on real-time supercomputer modeling. We are replacing the moon's natural gravitational regulation with our own brute force technological regulation.
We had to synthesize our own gravity, in a way, and the text outlines that eventually the effort actually works. The oceans stabilize, the violent, erratic sloshing finally burns itself out, and the tides return to a new, normal pattern.
A very different normal, but yes.
Yeah, likely driven purely by the sun and heavily managed by our new coastal infrastructure. Once the physical environment stops actively trying to drown the continents, the immediate, frantic survival phase essentially ends.
And that stabilization of the oceans marks the transition from physical catastrophe to profound psychological processing. The author uses this exact pivot to shift the narrative from a speculative disaster scenario into a deeply philosophical examination of humanity.
So what does this all mean? The text asks us to look at the moon's disappearance not just as a physical absence, but as a metaphorical wake-up call.
Right.
We spent the first half of this scenario panicked, running from the water, and mourning the loss of our time and our light. But as the years pass and the memory of the moon lives on in the survivors, it changes. The moon transforms from a physical rock into a symbol of our planet's extreme fragility.
It really forces a collective reevaluation of humanity's relationship with the natural world. I mean, think about how completely we take the mechanics of our solar system for granted. We assume the sun will rise, we assume the tides will ebb and flow, and we assume the climate will remain within a survivable bandwidth. The author proposes that it takes the ultimate cosmic trauma, the sudden deletion of our nearest neighbor, to brutally expose the delicate, razor-thin margins of our planetary ecosystem.
That phrase, wake-up call, implies that humanity had just been sleepwalking. We've been sleepwalking through the precise, terrifyingly delicate balance of physics that literally keeps us alive.
Yes.
The text explicitly links this realization to a renewed, aggressive focus on environmental preservation. It took the darkest nights in human history, the flooding of our cities, and the warping of our very perception of time to make us realize that we do not have an infinite margin for error on Earth.
Catastrophic loss frequently acts as the primary catalyst for rapid leaps in human consciousness. We are, at our core, a reactive species.
Yeah, unfortunately true.
The disappearance of the moon in this speculative piece completely strips away our complacency. But the author's ultimate lesson is incredibly optimistic. It really is a lesson about hope, growth, and change.
Which is an incredible destination to reach, considering we started this discussion in pitch black terror.
Because the void left behind didn't remain empty. The physical void allowed us to see deeper into the galaxy, discovering new stars and planetary bodies.
Right.
The engineering void forced us to invent protective technologies that redefine our entire relationship with the oceans. But the psychological void is where the real growth happened. We gained a renewed, visceral appreciation for the Earth itself. We learned that even when the most permanent, beautiful fixture in our reality is torn away, the human capacity for adaptation is just limitless.
It is such a powerful arc to trace in this deep dive. I mean, we walk through the terrifying breakdown of gravitational physics, the violent collapse of the oceanic tidal bulge, the bizarre stretching of time and the axial wobble, and then the mass ecological disruption of endless darkness.
It's hard to process.
It really is. Yet, humanity engineers its way out of the deluge and uses the new black sky to map the universe. It is a masterclass in not taking our natural balance for granted. I really want to thank you for joining us on this deep dive, by the way. I feel like the source material provides a perfect aha moment about the delicate balance of our natural world.
It perfectly illustrates that our existence is a fragile privilege, maintained by forces we barely pause to acknowledge.
Absolutely. If you are walking outside tonight and you look up to see the moon doing exactly what it has done for billions of years, it is impossible not to view it with a completely new level of reverence. It is not just a rock, it is the anchor keeping our oceans calm and our days predictable.
The author gives us a brilliant lens to examine our own vulnerabilities here. It leaves us with a necessary provocative question to consider. If the sudden loss of something as distant as the moon could completely reshape our collective consciousness and force us to finally protect our natural world, what vital, permanent fixtures right here on Earth are you completely taking for granted today? And what will we be forced to learn if they vanish tomorrow?